Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 2641 cousins in binary tree second. Before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes to this problem. So let's get right into it. What problem is asking that you will be given a binary tree. Let me make it for you quickly. So this is a binary tree that you will be given, and what you have to do, replace these node value with the sum of cousins. That's what you have to do. And what is a cousin? You can read over here. I'll highlighted also. Same depth with different parents. So let's see if it is a binary tree like this. So consider this 1, 2 and 3. We are considering these three nodes, and see 1, 2 and 3 are present at depth 2. This condition is all right. They are at same level. But what other thing we have to check is parents. 1 and 2 have same parent. 3 has different parent. Different parent. 3 has different parent. So this condition is false. 1 and 2 are related to each other. So what 3 is, what it implies, 3 is a cousin for 1 comma 2, and 1 comma 2 is our cousin for 3. So what value will be over here? If we talk about sum of cousin for 1 comma 2, cousin is 3, so value at 3, whatever value at 3 will be over here. Same value at 3, whatever value present at node 3 will be over here. But here for 3, 1 and 2 are cousin, so same parent, different parent. And 3, what will be at 3? The value of 1 plus 2. Whatever value is present at node 1 and 2, we do their summation and put it at the value, not at the value, at the node 3. So this much is clear what is cousin and how we are doing sum of cousin. So let's see how we are doing it. So let me draw that tree quickly. Binary tree. Four, 9, 1, 10, 7. So this is binary tree that will be given. So for 5, there is no cousin. So what we will do, if there is a no cousin, 0. Same case with 4 and 9. 4 and 9 are present at level 1 or depth 1, but same parent. So no cousin, so 0. Now let's check these 3 at level 2. But 1 comma 10, same parent, and 7 have different parent. 7 has different parent. Parent is 4 and parent is what it is written, 9. Parent are different, but 1 and 10 are same, because 4 is the parent of 1 comma 10. So which is left is 7. So 1 will be replaced with 7, 10 will also be replaced with 7. But in the case of 7 has 2 cousin, 1 and 10. So we have to do the summation. So 1 plus 10 will be over here. So this is what we will be doing. Let's make the changed binary tree for you to have a better visualization. So this is what that tree is transformed to. So this is the tree. We have to return this tree as a answer. So this much is clear what we are doing. Now we have to answer how to do it. So let's see. Let's take this level 2 only, and see how this 7 present here. 1 7 10. I'm not making that tree again, just we are concerned with 1 7 10. So what is the sum at this level? Sum is 8 18. 18 is the sum at level 2. Level 2. This is the sum at level 2. If there is a question why we are doing this, there are two ways to get the sum of cousin. First way is calculate sum of cousin, and another one is total minus something will get us sum of cousin. There are two methods. This one is easy and intuitive. I don't know about this one. We are talking about this one. So that's why we did total. So we have 18. We have sum 18, level sum 18. And what we required, this node has sum of cousin 7. That much is clear. So how we get that 7? I just wrote wrong over here. It's 10. It's 10. Sorry. It's 10. This is 7. How we get that 7 over here? Is by subtracting the value of node and the value of 10. That's how we get 7. So what is this? 11. What is this 11? What is this thing that I left? Is the sum of sibling. 1 and 10 are sibling of each other. 1, 10 are sibling of each other. You know why? Because same parent. So how we get that sum of cousin? Sum of cousin is total sum of level minus sum of cousins. Getting the sum of cousins is very easy. How? Before going in this call, you can access this left and right and do the summation and do send it in the right call or left call, whatever it is. You will see that is about coding part. But this is easy to calculate because sum of cousins or is easy in this case because total sum can be found very easily, and other thing is sum of cousins we can also find that easily. When we find these two things, we can get sum of cousin. So this is clear that how we are going to get that sum of cousin. We have to get the total sum of that level and also the sum of cousin. This much is clear. Now let's see how we get that total sum of level. So what we will be doing is, for that is we will be using DFS, very basic thing. And what we will do, we will make a unordered map, unordered map of this type, level sum or depth sum, whatever you want, level or depth, whatever you want to write. And what this will hold is d, the depth, and this is the sum. So what we will do is, we will do one DFS to calculate the depth sum or level sum. So what we'll be doing over here is, for depth 0 we will have certain sum, for depth 1 we will have certain sum, and for depth 2 we will have certain sum. This is easy. I will show you that in the coding part. Basically it is a basic traversal, and another DFS would be done to find this, not find this, not find this, to find this, to find this, and we will get that while doing that DFS along the way. So how we gonna get that sum of cousins? Now we are discussing sum of cousins. So how we are doing that? This is, we have stored, we have level sum, we have level sum over here, level sum is present. So what we will be doing is, that sum of cousins is, sum of cousins will be level sum at that depth, whichever depth we are, because we have different sum at different depths, minus the siblings. And how we get that sibling sum? Sibling sum is very easy. How we get that? Node left value plus node right value. Why I wrote this after this? Because in root node you will see it is a basic DFS call. I am just explaining it. So in first DFS call we will be doing this depth sum, we will be calculating depth sum or level sum according to it. And in second DFS what we will doing, we will find the sum of cousin. How? The sum of cousin will be level sum at that depth minus the sibling sum. And how we get that sibling sum? It is this. Now let's see the code to understand it, because I have to explain it two times. That's why I'm not discussed till now. So let's see the code and I will explain that over here. So this is the depth sum unordered map. So what we are doing? We are doing just the basic traversal. And what we are doing? We are just storing the depth sum. For every depth we are storing the node value. That is pretty much clear. And what we are doing? We are going left and we are increasing the depth by +1. Similarly, while we go right, we increase the depth +1. Basic traversal, you should know this. Other thing, the update tree function, where we update this tree, where we find the sum of cousins. So this is very basic thing. Whenever you reach null, just return it, because void. What we are doing? We are doing sum of cousins or root value we have to change. So what we are doing? We are doing depth minus sibling sum. So when we are at this, let's see, when we are at this 5 root node, so the sum over here, sum, so at level 0 sum will be 5, and sum of cousin, what is sum of cousin? 0. And what is the sum of sibling? For this case, for this particular case, we have to use its own value because it has no sibling, but we have to have 0. That's why we are using that. So you can see in this call for only the root. That's why I didn't discussed over here, because we have to change this root to 0. So you can see for the particular root node, the sum of sibling is him itself. So what we do, 5 minus 5, we get 0. That's what we do. Now what we are doing over here is calculating the sibling sum for next node. That's what we are doing. So if we have left, what we do, we calculate get the left value, else we get 0. If we have the right, we get that value and we do that. And what we do, we get to the left, and what we do, we increase the depth and send the sibling sum. Because at this level there is no sibling, but when we get at 4, we have the sibling sum. 1, 4 and 9 are siblings of each other. So what we have, 13. And at this depth, level sum is also 13. So that's why when we are at this, so what happens when the left call execute, 13 minus 13, 0. And over here same thing happens, 13 minus 13, 0. So that's what we are doing. Sibling sum, I already told you, sibling sum, both 4 and 9 will be included, not only 9. 4 and 9 both will be included. That's what we are doing over here. We will keep doing it, and after that we will just return the root. So let's dry run this to have a better understanding. Let me get the code one by one. So and let me get the main call also, because you will be little confused in the case of root node. So let's get that also. Let me snip it. Yeah, this is it. So we'll make that map over here. What is the name for that map? It's depth sum. So what depth sum will be looking? Let's get the test case also. Where is the test case? This is the test case. Copy. This is the test case. Let me zoom it out. Yeah. So for level 0, what is the sum? As you can see, level 0, level 1 and level 2. For level 0 sum is 5. For level 1, this is what whole code is doing. You can do it on your own, not wasting time over it. How much is this? 13. And at level 2, what we will have is 18. This is what we will get after this. Now what we are doing, let's make the map, not map, let's make the tree to have a better understanding. 4, 9, 1, 10, 7. So let's change the pen. Yeah. So what comes over here, you can see this call 0 and root value. What is the root value over here? Root value is 5. So we have sibling sum 5, depth is 0, and root node. So what we do, what value we are accessing? This 5. So what we do, depth sum at 0 is 5. 5 minus sibling sum 5. How much it is? 0. This is done. And now let's calculate the sibling sum. So what is the sibling sum? As you can see, we have left, we have right. So what we do? We do the summation. So 4 plus 9 is 13. So what we do? We just send 13 over here. 13 depth plus 1. So let me write over here. Now it's 13. It's 1. It's 13. It's 13. It's 1. It's now looking like B. It's 13 and it's 1. We get a 13 and 1. Let me write over here. This is the call. This is the call. So at this level, what is the depth? 1. We are at depth 1. So what we do? Depth sum D over here minus sibling sum. What we are having here? Sibling sum 13. So 0. Again we get to this call. So before going to this call, what happens? You can see we again calculate the sibling sum. So call would be looking like this. 2 depth increased, and also sibling sum, because we have left, we have right. I hope this much is clear. So what we have is 11. We have 11. Now we are at what? Depth 2. We are at depth 2. So at depth 2, what is the value of that level? 18 minus sibling sum, that is 11. So what we get? 7. This is how it's done. Now after right, we get to null. We just return it and we go to the go to the left. Now from left we get to the right part. So in right part, the call is same, 2, 11. At this place, what we do? Again, we are again at depth 2. So sum is at that level is 18 minus the sibling sum. What is the sibling sum? 11. Again 7 over here, 7. And after that we just do backtrack, and after that same thing happen over here. What happened with 4? 13 minus 13. And but it at this place it will be different. What will be different is sibling sum. We don't have anything over here, but we have 7, so we can get this as 0, 7. What is the sibling sum for this? What will be the call for this? Let me write over here. Call will be 2, 7, because 0 plus 7, 7. So at 2, at depth 2, what is the level sum? 18 minus that sibling sum 7 minus 7. What we get? 11. So we here do the 11 and we just return the root. As you can see, I hope this much is clear. Let's submit it and see if it is running or not. Yeah, it is running, submitting, and I hope this is clear. And if it is, so consider subscribing to the channel, liking this video and sharing with others. Consider subscribing, because 95% of the people don't subscribe. So consider subscribing. It takes effort. So, and subscribing and liking this video just motivates me. So in the end, you have to do what you have to do. So keep grinding. You guys are awesome. See you in the next one. Bye bye.